In this video, we'll be taking a look at arguably one of the most popular tools in Alteryx, known as the formula tool. So what is the formula tool used for? Now, we are all likely to have experienced data that is fed from upstream systems or a particular data source that has some form of data quality issue, and it requires a bit of cleansing before it is in a state to perform some form of visualization or calculation on it. The formula tool is great at addressing data quality issues that may exist in particular fields within your dataset, but better still, the formula tool allows you to create fields within the dataset that may otherwise be omitted or simply not available. Now, more strategically speaking, correcting data quality issues upstream would be of preference, as it would mean we would consume the data without having to cleanse it. However, in reality, getting upstream changes or changes to source files may take too much time, it may be too costly, or just may not get prioritized against more important items within the system owner's book of work, and this is understandable. So Alteryx enables us to implement semi-strategic fixes to data quality issues that may otherwise be expensive to address. Now, the formula tool can leverage many different functions, and we will explore how we can locate each of them shortly. But this video will not address specific functions. The main goal of this video is to understand what the formula tool can be used for, and you should look to cover the array of functions available in your own time. So let's first drag an input tool onto the canvas and connect to a new dataset called city populations, which gives us some very basic information. We have state name, city name, and a value representing the population for each city. We will then drag a formula tool so that the input's output anchor joins the input anchor of the formula tool. Okay, so the first thing we're going to do is simply add another column onto our dataset, which tells us the data source name. This way, if we use it in subsequent parts of our workflow, we know exactly where the data has come from, acting as a good audit trail. Now, in the configuration window, we have a simple box in which we can incorporate specific logic. Now, the logic we include can leverage many different functions, just like functions in Excel, functions in Python, or the functions in Tableau when creating calculated fields. So if I click on the little FX button here, we will be able to see different functions and the respective parameters we have available. So if we wanted to create conditional statements, which we will do shortly, we can click on conditional and see what functions are available. If we wanted to see what functions we can perform on strings, we can click on strings and we can then use these functions accordingly. So we'll use starts with as an example later on. So the first thing we said we were going to do was add a new column stating the dataset name. So we can click on the drop down and select add column. And then we can give the column a name. So in this example, we will call the new column data source. Seeing as this column will simply hold a string value, i.e. text, we will change the data type to a v string. Now, seeing as this value will be constant, we could choose a string data type, as this holds string values which are fixed in length. But for this example, we'll stick to v string, which allows us to include variable length Latin 1 characters, which for our purpose is absolutely sufficient. We will also change the size to be 20, i.e. the field will contain a maximum of 20 characters. Now we will enter into the white box what we want to be evaluated for each line. So in this example, we will simply want every line in our dataset to be given a string called city populations. So let's type city populations, and this will then be applied to each line. Now you will hear me say each line often, as it's important to recognize that the formulas or logic you include are applied to each line in the incoming dataset. So we'll add a browse tool to our formula tool, and then we can run the workflow. Now the logic has been applied to close to 30,000 lines in a fraction of a second, and we now have a new column in our output called data source, which states city populations for each row. Great. Now the next thing we want to do is update a data quality issue using some logic. Now this data quality issue has been made up by me for illustrative purposes, but let's assume that the city called Abanda does not have a population of 192, but in fact has a population of 1,000 people. Well, we can add multiple formulas to a single formula tool by clicking on the little plus button and the formula box is replicated. So in this example, seeing as we want to update the population column, we will select population from the drop-down list. Now the logic will be simple. We will include a conditional statement, and our conditional statement will state if city, and notice here that when I start typing a column name from the incoming dataset, Alteryx will provide recommendations as to what you may be looking for. So if city equals, and then we will have this set as the string abanda. Then we want to provide the population with a value of 1000. Else all other cities will simply keep their original population value. So we can type else population. We can then end the if statement by typing end if. When we now rerun our workflow, you will notice that we still get our newly added column called data source, but this time we have a result set that has updated the population of Abanda to be 1000 rather than the original value of 192. So this newly updated dataset can then feed its way through other tools for further transformation and analysis. Okay, so let's keep going through some examples. Next, we will create a population rating column, which will categorize our populations into low, medium, and high. So for this, we will add a new column called population rating, and we will set the data type to be vstring with a size of 10. Our logic will be conditional, and we will state if population is less than 1000, then we want the string returned to be low for that row in question. Else if the population is less than 10,000, then we want the rating to be medium. For any row that does not meet the first two criteria, we want the value returned to be high, so we can type else high. We can then end the conditional statement by typing end if. Before I run this workflow, I want to point your attention to what Abanda's result ends up being. What do you think it will bring back as a result? Low, medium, or high? Well, let's find out. When I run the workflow, you can see we obtain a new column called population rating, and each row is provided with a value as per our conditional statement. Now, in the case of Abanda, we obtain the value medium. This is because the population column has been updated before the application of the population rating column. So the order in which you provide multiple formulas in a single formula tool will influence the output, and I will showcase an example of what happens when you change the order shortly. So we're now at the point where we've created two new columns and corrected an existing column. Let's observe another function by creating a new column in the dataset. This time, we will assume that a fictional company will assess new regions to set up a new branch and will carry out the investigations in two phases. Phase 1 will be those cities that start with A and have a low population rating, and the rest will be Phase 2. So let's add another column and label this column Observation Rating. This column will be a vstring data type with a size of 20. We will write a conditional statement by firstly stating that if population rating equals low, which has been set from the prior formula, and, so here we are introducing multiple statements, and, now here we need to check that the city starts with A, so we can go back into our function list and select the string function that performs a start with operation. The first parameter we need to enter is the field in which we are checking. So in this example, it's city. And then the second parameter is the value we are checking for. So in this example, we are checking for the letter A. If a row in the incoming dataset meets this criteria, then we will set this as phase 1. Else all other records will be tagged with a string called phase 2. When we rerun the workflow, as expected, we get another column called observation phase, which splits our close to 30,000 rows into phase 1 and phase 2. Great. So let's finish with a couple of examples where we use numeric values as opposed to strings. Firstly, we will add another column which assigns a forecast growth percentage to each row. And this will once again be conditional in nature. So we will call the column population forecast percentage, and here we will simply state that if population is less than 10,000, then we will state the growth forecast to be 10%, i.e. 0.1. Else, if the population is less than 30,000, then the forecast growth will be 15%, so 0.15. Else all other rows will be applied with 20% forecast, so 0.2. Rerunning our workflow will give us a new population forecast percentage column. Now we can use this column to create a new column which performs a calculation on specific values. So let's create our final column called forecast population. And here we will simply multiply the population field by 1 plus the population forecast percentage. And to anticipate the formatted output, seeing as we can't have a fraction of a person, we will floor the result to the nearest integer, i.e. round down to the nearest whole number. So here we're using a new function and performing calculations for each row, taking values from either existing fields or fields that have been created from the formula tool. Now when we run the workflow, we get a final column which forecasts the new population. So here we've covered numerous examples as to how we can build up a more enriched data set whilst also covering a small data quality correction example. Now as mentioned earlier, the order in which you create fields or change existing fields is important. In the examples we've covered, we have first changed a data quality issue within the population field, i.e. we've changed the Abanda population to be 1000. Seeing as the population field is then used in the population rating logic, we then show a population rating of medium. However, I'm able to move the order in which the columns are calculated. So if I were to move the population data quality change to the bottom of all other formulas by clicking on the left-hand side of the field on the 4 little lines and then dragging the field to the bottom and then rerun the workflow, you are able to see that the population rating and the observation phase has already been calculated to be low and phase 1 from the original value of 192. Therefore, always try to get in the habit of correcting data first. If you have a formula tool that utilizes a field that has erroneous data, and other fields are dependent on that field in some form of logic, make sure the data is corrected first. If you don't, you may get erroneous results which impact decision making. Once again, whatever your formula tool outputs can then be fed into subsequent tools in your workflow to really control the way you want to transform your data.